everyone. Welcome to IMW Clean Tech Webinar Series May webinar, LNG Tech 101, Overview of Cooling, Storage, and Fleet Fueling. Your speaker today is Dave Dixon, Professional Engineer at NorthStar LNG. Your host is myself, Amy Little, Marketing Coordinator at IMW Industries. IMW has been manufacturing industrial machinery since 1912 and has evolved to be a leading manufacturer of natural gas compression systems servicing all major markets globally. Equipment is currently operating mid-east to north of the Arctic Circle. In addition to our CNG solutions, we now provide a full range of LNG products using NorthStar technology. Below are some of these products. IMW and NorthStar alike operate as wholly owned subsidiaries of Clean Energy Fuels. Clean Energy is the largest provider of natural gas fuel for transportation in North America and a global leader in the expanding natural gas vehicle market. Clean Energy has operations in CNG and LNG vehicle fueling, construction and operation of CNG and LNG fueling stations, biomethane production, and compression technology. This webinar will qualify for 1 hour of technical informal continuing education credits in most jurisdictions. For more information or to request a certificate, please send your name, title, company, and email to webinars@imw.ca. We'd like you to get involved and ask as many questions as possible, as questions are an important part of this session. We'll have at least 10 minutes at the end of this webinar, so please enter any questions you may have in the chat box provided. Now I'm pleased to introduce your speaker, Dave Dixon. Dave has 13 years of experience in the LNG vehicle industry with NorthStar LNG of Evanston, Wyoming. NorthStar is now part of Clean Energy Fuels as well. Dave has been responsible for the engineering on over 100 LNG vehicle fueling facilities for municipal bus and waste hauling industries and public LNG fueling stations. Dave holds a Bachelor of Science in Mechanical Engineering from the University of Wisconsin-Madison and a Master's of Business Administration from St. Cloud University. Over to you, Dave.
Thank you, Amy, and thank you, everybody, for joining us today. Can you see my screen? Amy, is that shared?
I'm just doing the handoff now, Dave.
Okay, I'll wait a second.
So you should just hit the play button now on your interface and be able to share your screen.
There you go.
Great.
Very good, thank you. Okay, the title of our topic today is LNG Tech 101. Amy already introduced myself and NorthStar. I had a slide on that, but I'd like to say a couple words about NorthStar. We're based in Evanston, Wyoming, and have been exclusively in the LNG business since 1994, primarily building LNG fueling stations and CNG fueling stations, which is CNG made from LNG. We have built over 30 stations before being acquired by Clean Energy Fuels in December 2010, and well over 100 since then for both clean energy and also for private customers. The things I'd like to talk about today, anytime we have the word numbers 101 in a title, I should give some basics of LNG. I'll give some safety and property information of LNG. Then we'll start discussing LNG vehicle station technology, what the stations are made of, how they work. We'll discuss LNG vehicle fueling and then CNG vehicle fueling, and then leave time for questions at the end. So basics of LNG. Probably most of you have seen some of this before, but for the benefit of those who might not have, I'll kind of go through this quickly. LNG is simply natural gas that's been refrigerated to -260 Fahrenheit, which reduces its volume greatly, 600 to 1, and gives it a final density of about 3.5 pounds per gallon at 0 psi. Now this is a little less than half the density of diesel fuel, but it is quite a bit more dense than CNG, and it's that density comparison to CNG that really makes it viable as a vehicle fuel for many applications. LNG is made typically at liquefiers that can be dedicated for vehicle fueling. Clean Energy has 2 of them in Boron, California and Willis, Texas, and then the rest of the fuel in the market can come from peak shavers. Peak shavers, which are just natural gas utilities, who are selling excess LNG into the vehicle market that they don't need for buffering their pipeline operations. LNG is predominantly methane. As we manufacture in our liquefiers, it's typically 97 or 98% methane with a little bit of ethane and propane as trace elements. And this is also typically better than pipeline gas that might be in the CNG compression business, which can be a little more variable than that. So that's also one of the benefits of LNG. LNG is colorless, odorless, and non-toxic. As far as I know, no attempts have ever been made to odorize LNG in the vehicle business. So it's typically not odorized, which means we use methane detection as safety devices to detect a leak or a spill. LNG is flammable after it vaporizes and mixes with air. Not flammable as a liquid, but as a liquid it will boil off rapidly, mix with air, and then become flammable. That's the whole point of LNG as a fuel after all. Cold methane is denser than air and can settle in enclosed areas. Once the methane warms, it will rise and disperse as long as it's not inside a building or other enclosure. So the fueling we do typically is out in the open air. There's nothing to prevent the methane from rising and escaping if there is a small spill, so it's relatively safe in that regard. A more recent application is to make LNG from landfill gas, which is a renewable resource and prevents that methane from going into the atmosphere as a pollutant. And trash haulers especially like that because that gives them a landfill to truck fuel source of fuel. Some of the basic hazards, as we said, methane is flammable, but only within a specific range of concentration in air, about 5 to 15%. Outside of this range, it's either too lean or too rich to burn, and is safe in that regard. Since the LNG is at minus 260, there is a hazard for frostbite or freezing if there's direct contact to the skin or eyes especially. So we always want to avoid that. And then asphyxiation due to displacement of oxygen is a concern only in enclosed areas generally. Buildings or other enclosures are the main risk there. Again, our fueling stations are typically very open in the outside air, and asphyxiation is not a real concern for that application. Some basic safety equipment we always recommend: cryogenic gloves, a face shield, closed shoes or boots, long sleeves, long pants. One thing for operators and fleet managers to be aware of is I've seen over time that LNG fueling becomes so routine that operators sometimes don't always put on the right safety equipment. Especially in hotter climates, they may not want to wear long sleeves or gloves. And I think it's always important to be vigilant to recommend and stay up with the protective equipment and training of the operators. Some basic hazard prevention then is just to always follow the recommended operating procedures, wear the protective equipment. If there's a leak, avoid it and contact the technician to repair the leak. Don't handle cold hoses and piping without gloves. Always keep sources of ignition away, especially smoking. The vehicles themselves, as they pull in for fueling, are not considered a source of ignition per the code. So the normal vehicle traffic is okay, but other vehicle traffic adjacent to the station, we'd like to keep that at least 15 feet away so we aren't bringing another hazard close by. And finally, perform vehicle maintenance in a proper area. That means if you work on LNG stations indoor, LNG vehicles indoors, then building modifications are typically performed for ventilation and methane detection. First aid is pretty simple in case of a burn due to a fire, frostbite due to contact with LNG, or asphyxiation. Basically use common sense and seek medical attention wherever appropriate. Okay, now the LNG stations themselves will be the focus of our discussion. That's our background here at NorthStar and our specialty. I'll kind of discuss the storage tanks, pumps, dispensers, offload systems, safety systems, and PLC control systems. These are the major components of any LNG fueling station. First, the LNG storage tank. Currently, in the U.S. at least, we are building stations with 18,000-gallon gross capacity storage tanks with 175 psi working pressures. The net capacity of LNG we're allowed to put in these tanks per code is 90% of the gross capacity, and that's true for whatever size tank you might go with. In the U.S., we're also building most of our stations with the foundations to allow easy upgrade to 2 tanks, and many of our customers would have that feature as well. We also, for sites that have no provision for future expansion, they would just get a foundation for a single tank. Now, we aren't limited to 18,000-gallon storage tanks. We have built stations with up to 30,000-gallon storage tanks for customers with large fleets and high usage requirements. So in sizing the tank and selecting the right tank, some considerations to take into account. The daily amount dispensed is important because LNG is delivered to the stations at 10,000 gallons at a time in LNG tanker trucks. And what we'd like to be able to do is use the fuel in the station to the point where it can take a full 10,000-gallon tanker load. And at that point, we need to have a window where we can refuel the station without running out. And if you have a very high usage station, that rest of that fuel may be consumed very quickly, and that makes the logistics very difficult. So at a certain point, if usage goes up, then larger tanks or a second tank would be warranted for consideration. Another factor to consider is that per code, LNG stations are required to have spill containment around the tanks. You can see in the photo here the concrete block wall that surrounds the tanks. The spill containment has to be sized for the entire contents of the single largest tank that's in place. So the bigger the tank, the bigger the footprint of spill containment. And additionally, the larger tanks require larger setbacks to property lines. In most jurisdictions, up to 18,000-gallon storage tanks have to be 25 feet from the nearest property line. And then above that, the setbacks get larger. So that's a factor in how you can place the station on site. On-site days of storage. Some customers, especially mass transits, like to have 2 days or 3 days of storage capacity on site just to ensure that the buses can roll in the event of a delay in deliveries of LNG. Most of the time, this is way more than necessary, and if proximity to a liquefier is good, then much less storage than that is really needed to have a functional station. And finally, we get asked sometimes, why do we usually use vertical tanks versus horizontal? There's a couple reasons for that. Vertical tanks are typically a little less expensive. Vertical tanks have slightly less footprint on the site than the typical horizontal tank. And the vertical tank gives us more liquid head, which makes it easier to prime the pumps. However, we can get around that with horizontal tanks by raising them up on piers, typically about 5 feet above ground, so that for the horizontal tank we can prime the pumps just as well, even when the tanks are nearly empty. The next component of a typical LNG station is the dispensing pumps. At NorthStar, we use ACD model TC34, which is a submerged centrifugal pump. This pump has a motor and impeller assembly that are integral to each other. This pump is installed in a small pressure vessel, which you can see in the photo, with a flanged lid. These pumps are directly adjacent to the storage tank, as close as we can get them, so we have minimal pressure drop from the tank to the pumps, which helps priming and assures good operation. As a standard practice, we design our dispensing systems to flow 40 LNG gallons per minute to either 1 or 2 dispensers. In practice, if we're feeding 2 dispensers simultaneously, it might be more closer to 35 gallons per minute at each dispenser, but those are our targets. Most of our stations we're building have one pump in service to feed 2 dispensers, and we'll put a second pump in place as a spare, which you can see in the photo on the left without any frost on the lid. The reason for that is the pumps are quite reliable, but when one does fail, it's approximately a 4 to 8 hour project to disconnect the piping, the electrical wiring, and remove the pump and replace it with a new one. So to avoid that potential of outage, we put a second pump in place as a spare that can be put in service in a couple minutes. And finally, the pumps are variable speed, and we control the speed through the PLC that drives a variable frequency drive. And we do that because we're trying to maintain an optimum flow rate and pressure to the dispenser so that we can maximize the flow rate that the vehicle gets, minimize the time it takes to fill the vehicle, and also avoid any issues with overpressurization of the vehicle. So that's all controlled by the computer automatically. The next component I'd like to mention are the LNG dispensers themselves. There's a couple different types that NorthStar is using right now. The main ones are what you see in the photo here, which is a LNG dispenser that uses Gilbarco chassis and electronics that we add our LNG piping and controls to for the LNG process. So this comes complete with a card reader and receipt printer, and then can communicate with most typical types of fuel management systems. We do have a national weights and measures type approval for this dispenser, and to be fully weights and measures certified, you would also demonstrate accuracy to your local jurisdiction upon startup, which we have been doing for our customers lately. Most jurisdictions do not have the right test equipment and don't know what LNG is, frankly, so typically we will go on site with our test equipment and technicians, demonstrate the accuracy for the weights and measures officials, and then we can get official certification sticker on the dispenser. One issue of contention right now is the unit of measure, the DGE or diesel gallon equivalent, is not fully certified yet by weights and measures authorities. That is scheduled for a vote this summer, and hopefully they'll pass it, but that's up in the air. And another result of that is that every provider of LNG has a slightly different conversion factor. We use 6.06 pounds as the definition of 1 diesel gallon equivalent. I know that other suppliers have slightly different conversion factors. I saw one the other day at 6.024. They're not that far different, but it does raise some issues, I think, in the industry, and hopefully they get that passed this summer so we can all use the same basis. Another feature of the dispenser is that we have to accommodate vehicle venting when the vehicles need to be vented. Westport HPDI, high pressure direct injection tanks, vent back through the fill nozzle, and we can accommodate that. And we also have a vent hose for venting other non-Westport vehicle tanks. Go to the next slide. Now the fuel stations are loaded with LNG from tanker trucks, and we use this pump on board the LNG station to pull the LNG from the tanker truck and pump it into the storage tank. Now there's a bunch of different pumps that are suitable for that. We use the same pump design and pump can that we use for our dispense pumps, and for us, we feel that this gives a faster cool down, good priming, and also lets us use the same parts for both dispensing and offloading. One factor to consider is the location of the offload connections. We like to place them on the back of the station opposite the dispenser so that while you're offloading a tanker truck, you can still be dispensing to vehicles. If your site does not have the room to allow that to happen, or the traffic patterns, then we can put the offloading on the same side as the dispensers, but now you're blocking at least one lane while offloading is occurring. Typical pumping time for offloading is about 70 minutes or about an hour and a half if you include the time to connect the hoses, cool the pump, and then disconnect the hoses when you're complete. All LNG stations have a safety system, including an emergency shutdown system. This is largely dictated by code requirements. Typical implementations will have fire detectors viewing different angles of the station, methane detectors at different locations, emergency stop buttons, which are typically at all the dispensers and at other sites around the perimeter of the station. And if any of these devices are tripped, immediately all the valves on the station are closed, the pumps are stopped if they're running, and we remove power from all the electrical equipment that's in the LNG dispensing areas or containment area. So that way if there is a leak in progress, we minimize the chance of a fire by taking all the electrical sources out of action. The important thing to remember too on this, if this system is activated by code, it has to be reset manually at the station. We can't log in and reset that remotely. So it has to be by a technician who is verifying that the station is ready to operate and any issue has been repaired. I think we've mentioned the spill containment already. That's a standard code requirement in the U.S. We also include an auto dialer or fire alarm control panel. So in the event of any type of emergency alarm or process alarm, such as low tank levels, we can program that to call out to either Clean Energy, if it's a site we manage, or to our customer, or to a third-party monitoring system. And finally, we include on our stations a PLC control system to automate the operation of the station. So the PLC has transmitters which allow it to monitor tank level and pressure, the temperature, pressure, and speed of the pumps, the flow and temperature and pressure at the dispensers, and also for the offload pump. The PLC has operating logic which automatically runs the various processes so that the operator has to do very little except press start and allow the system to operate. A standard feature that we're also using for the past 6 or 7 years is to have a built-in web server in the PLC. And what this means is that if we have remote access either through high-speed internet and a VPN or through dial-up modem, you can dial in to the site, and with nothing but a web browser and the right password credentials, you can log into the station, see what's actually happening right now, as if you were standing at the control panel right on the site. So that's a huge benefit for remote troubleshooting, for maintenance, for checking the status of a station, scheduling liquid deliveries, just in general helping the station run correctly. Now the PLC we program to automatically recover from as many faults as we can, but there are some conditions that may require technical assistance. And as an example, that might be a sensor failure that's out of range. So in those scenarios, we can program the auto dialer to call out to either our technicians or our customers, depending on the location. They're required to then respond to that and repair the problem. Additionally, the PLC has parameters, so we can adjust things like pump settings, pump operating logic, alarm settings for, say, high liquid level or low liquid level, and basically everything that describes how the station operates. For our standard stations, these are all fairly set, and we just adjust them at commissioning and then we're done. For custom stations that are a little more exotic, there might be a little more of a process to monitor the station and optimize its performance. And finally, one other thing we do with our PLC is we collect data in the event of an alarm. We save data to a data file of what was happening before and after that alarm occurred so that we can download and analyze what happened and troubleshoot the problem. Some additional things to consider in terms of LNG stations. Through Clean Energy, We have built over 120 public LNG fueling stations, and we also have competitors that are building them as well now. So if a public station exists in a convenient location for a particular fleet operator, that's a viable option for fueling, and that takes all the maintenance and operations off the hands of the fleet owner. The question is, are those stations on the right routes or near the fleet yard where the fueling needs to take place? In some cases, the answer is no, and so as a result, we do build private stations for customers that have that need. And in that situation, the main considerations are going to be, who's going to maintain and operate the station. Many fleet owners would like to just contract that out to Clean Energy or another provider. How is that station to be paid for? In some cases, grant funding might be available to offset the cost, and Clean Energy typically helps get those grants allocated. If a particular fleet is starting with a small number of trucks, then a mobile fueler is maybe the appropriate way to go, and then start with that and build a permanent station later when there's more vehicles available. Another consideration is, should the station be sized for future expansion? We have some customers who we built stations for where future expansion was never envisioned, but yet 5 or 6 or 7 years later, they found that they had more trucks than they expected, and we needed more capacity. And so to retrofit later when that was not planned was very difficult, but if you think ahead, you can at least save some space for future tank or future dispensers. And then finally, in the private backlot scenario, we need the space for the station itself, plus the traffic lanes in and out of that station. That typically consumes quite a bit of space, or parking lot that was never envisioned for that fleet operator. A couple other things on stations. LNG dispensers, right now we're typically putting in a minimum of 2 just for redundancy. We don't have a lot of problems with reliability of the dispensers, but our attitude is that we should never delay fueling a customer, and if we have 2 dispensers, we reduce risk of a dispenser problem impeding fueling. Historically, NorthStar has recommended a maximum, or roughly 50 vehicles per day per dispenser as a comfortable fueling usage level, but every station is different and every situation is different. For example, if you are a fleet operator of, say, refuse trucks that go out during the day, come back in the evening, and you want to fuel them all in a short period of time, you may need more than 2 dispensers versus a fleet that fuels randomly throughout the day. So that needs to be considered in sizing the station. Typically at our stations we feed 2 dispensers from a single pump, but we're also putting in a second pump for redundancy reasons, as I mentioned. If you have a situation where you need 3 or 4 dispensers, then we would normally put in 2 dispensing pumps and perhaps a third pump for redundancy. And I think we had one customer who had very high requirements with 4 dispensers. We put in 4 pumps all in parallel, so we could have 3 in service at one time with the 4th as a spare, so they could get maximum dispensing flow rate no matter what the scenario. As far as the storage tank size, one aspect of LNG is that it warms up while it's inside the tank, and if the LNG stays in the tank for several weeks because the usage is so low, then what ends up happening is it gains heat through the insulation and piping and pump, and eventually we have to start venting. And so to avoid that, the ideal scenario is that we use enough fuel that we can take a new delivery of LNG every 3 or 4 or 5 days, sometimes 6 or 7 depending on the station design and the fleet design. And what happens is when we take a delivery of LNG, that cold LNG condenses the vapor, cools the tank back down, and kind of resets the whole station at a lower pressure again and starts the cycle all over again. So if the usage is so low that it's a week or 2 between deliveries, then really maybe a mobile fueler or a smaller fueling system would have been a better choice for that scenario. On the other hand, if the usage goes up to where a delivery is required every 2 days or every day, then clearly a single tank is going to become marginal and consideration should be given for multiple tanks or for dual tanks. So in general, we try to work with customers on sizing the private station so that we have the right station for the fleet and the way they intend to use it. So we're not adding cost unnecessarily, but we're also building a station that's going to work well. I'd like to go on next and discuss some aspects of the vehicle and the vehicle fueling. The way we look at heavy-duty vehicles for over-the-road trucks, typically define them as using 50 diesel gallon equivalents per day per truck, which is roughly 80 gallons of LNG. Typically, if the usage is much less than that, then I think perhaps the economics don't always seem to work out. But typically LNG, if you can use a lot of fuel every day, then that really makes the most sense for the investment that's needed. We dispense at roughly 40 LNG gallons per minute, which is 22 diesel gallon equivalents per minute approximately. So for what we define as a heavy-duty truck, the actual pumping time is 2.5 to 3 minutes or so to fill the vehicle. Now, there's also some time to hook up the hose, to initialize the fuel management system, and so the total throughput might be more like 4 minutes or 5 minutes depending on the operator, but it's really a very fast fueling operation. For the vehicle tanks, there's really a couple different types on the market right now. We show on the left here is actually a Cummins Westport vehicle tank, and that one is 119 gallons gross. On the right is a typical tank manufactured by Chart Industries. They're currently making, I believe, 119 or 150 gallon tanks. And many trucks I've also seen have dual tanks. They'll have one tank on either side of the chassis. And in those scenarios, they'll run the fuel nozzle for both tanks to the driver's side. And I've seen implementations of that where they fill both tanks from a single hose connection, and I've also seen them where they have to move the hose from one nozzle to the other to fill the tank on the far side. And so the selection of the vehicle system really just depends on the range that's envisioned before refueling can occur. One aspect of the engine selection, the Westport HPDIs, I've seen press releases that they are not taking orders on those, but we still fuel very many of them in the U.S. These are the systems that have an onboard high-pressure pump to generate approximately 3,000 or 3,600 psi to the engine. These types of systems can take cold, low-pressure LNG versus the spark-ignited systems down below, which require saturated LNG. Saturated LNG is basically just LNG that we've warmed up to raise its boiling point to whatever the engine requires, 50 to 80 psi, but 80 psi is pretty typical. And we do that automatically on the station after offloading if it's programmed in that way, so that whatever that fleet needs, we can provide the fuel at the right pressure to support that engine. And now more recently, Chart and Westport have both introduced systems on the low pressure 80 psi type of engine to allow those systems to take colder, lower pressure LNG. So they have an onboard pump or pressure builder to say take 20 or 30 or 40 psi LNG and still make sure they get 80 psi at the engine. Briefly, just some of the advantages of LNG. Without going into specifics, typically we're less costly than diesel, lower greenhouse gas emissions than diesel. That's lower CO2 emissions, although we have to be careful that we don't offset that with methane emissions. We have a nice consistent composition, typically 97% CH4. We have a pretty routine and automatic fueling process, and compared to CNG at least, we have higher density, therefore we can get more pounds of fuel in a given volume on board the vehicle. LNG tanks typically less expensive than the CNG equivalent for a given range. Offsetting that, we have to handle the low temperature piping and tanks, which is the personal protective equipment. LNG, if we park it for a long period of time, it will eventually raise in pressure and vent out the relief valve. That hold time will vary based on the vehicle, how full it was, what its pressure was when it was parked. We mentioned that we should do building modifications for indoor maintenance of these vehicles. And then what is the station availability? Is there LNG available where you need it, or can you build your own station? A typical LNG fueling station, as we've been building for the natural gas highway, looks something like this. And the current network, as I said, we've got across the country, east to west, north to south in the U.S., over 120 and growing, supported by 2 LNG plants and availability from numerous other sources. A couple words about CNG. It's really not the focus of our discussion today, but typically LNG is competing right now against CNG for the heavy-duty over-the-road truck business. CNG is pretty well known, but another option to consider is LNG to CNG, which NorthStar also manufactures. This might make sense where pipeline gas is not available to put in natural gas compressors. And one benefit of LCNG is that we have lower electrical consumption. It's much easier to compress a liquid than a vapor by a factor of 10 roughly, and so we have much lower electrical consumption and cost. By using LCNG, you get the benefit of the LNG composition compared to pipeline gas, which may be more variable. On the other hand, the LCNG is more expensive because we've got to liquefy the LNG, truck it to the site, and then make it into LCNG. So from a true cost comparison, very frequently straight compression CNG is going to be the most cost-effective way to get CNG if you've got pipeline gas available. Just to summarize then, for CNG, the main advantage there is it's a good fuel for light-duty, medium-duty applications. It's got more infrastructure. Clean Energy themselves owns and operates more than 400 stations. It's equally user-friendly, I think, also very good from a pollution standpoint, and you don't lose the fuel if you park for an extended period of time. Some of the negatives about CNG to consider: the heat of compression, which is on a fast fill system, is the warming of the gas on board the CNG tanks, which reduces how much gas we can put in. And then to consider the weight of the CNG tanks and what that does to your range and your payload capacity. And so then just to summarize, Clean Energy does own and operate 400 CNG stations, more than 120 LNG stations, so we're committed to providing either type of station or either type of fuel to our customers, whatever fits their needs the best. And so in conclusion, there's lots of opportunities for LNG as well as CNG, and we should all work together to see what we can do to take advantage of the opportunity. And that is all I had.
Hi everyone, it looks like we're getting quite a few questions, so I'll cover some of those off right now. Dave, what methane detector do you currently use?
We are using a General Motors methane and fire detector. And I should not quote the number off the top of my head, but we are using a catalytic bead style detector, not an infrared type. So it's a catalytic bead which responds to the methane, and we use a 4 to 20 output so we can read methane concentration in real time.
Perfect.
Okay.
Thank you. Do you use a standard relay panel wired to GD panel alarm output?
We have, I think that refers to the safety systems and the methane and fire detectors. We have a subsystem in our control panel that takes all of the inputs from the safety devices. It's not a separate standalone panel, but it's actually integrated into our control system as a sub-assembly. And that handles the signals from the methane and fire detectors and e-stop buttons and generates the emergency shutdown action that then shuts the station down. And I know on the market there are also standard sub-panels that you can purchase from different manufacturers, but we choose to use an integrated system that we manufacture ourselves.
Okay. How many heavy-duty trucks filling per day are typically required for an LNG station to be economic?
That is a very good question, and that's going to vary hugely, I'm afraid, based on a lot of factors. I don't know that I can give a concrete answer to that that's going to fit all situations. I think certainly I would like to see at least 20 trucks a day at a station to have the station operate in a good manner. Now, whether that will be profitable at 20 trucks per day or not, I really can't say because that'll vary with a lot of things.
Yep.
I think less than 20, if you're down in the 6 to 10 trucks a day range, to me that seems like more an application for a small temporary mobile fueler perhaps. And at some point then, more trucks would mean that a station would be viable.
Okay.
And that's just my personal opinion, again.
Yep. One more question on that, the portable system you just mentioned. Can they fuel CNG vehicles in the field?
There's more availability of LNG mobile fuelers right now. There are some systems that have been done for CNG, and they're typically there's a couple different kinds. Either it will be tube trailers that will be filled at a CNG station and then driven to a site where mobile fueling would take place, or there are some systems that have trailerized small compressors that can be put in place to typically do time fill of a small number of trucks, 4 to 6 to 8 trucks at a time. And both NorthStar and IMW are both working on those types of systems, but they're really not widely available in the industry right now.
Okay. How would you measure accurately LNG consumption?
That's typically done, well, on a fleet basis, we do that through the fuel management system. So every transaction at the dispenser is logged into a fuel management system, which we can then run reports to generate reports for the customer of usage per day or per month. We can look at number of trucks fueling, what those truck numbers were, how much fuel they took, and that can form the basis for seeing what was happening on a daily basis.
Okay. How is a single pump station design able to offload and dispense simultaneously? Aren't offload and dispense operations on different parts of the pump curve?
They are actually. What we found is that the way we design our piping and configure our control system, we are able to operate that dispense pump really at the far extreme of the pump curve. That is true. We are typically offloading with that TC34 around 150 gallons per minute, sometimes around 170 depending on pressure in the storage tank. And we have found we have been doing it that way for 14 years, and we have had zero issue with priming at that extreme flow rate. And that is, well, probably outside what ACD would advertise as the pump curve on that particular pump.
Okay, perfect. The delay in LNG tanking, is it equal to diesel? What's the comparison there?
The delay in tanking, I think that must mean the delay perhaps, or the fueling time required. I don't know if I can speak to that. I don't know the standard practice in the diesel industry and how much time that takes compared to LNG. I think that I can say that once a truck pulls up to an LNG dispenser, the time required to initialize the fuel management system, connect the hose, and cool down the meter to start dispensing as long as the vehicle tank does not need to be vented, is approximately a minute.
Okay.
And I don't know how that compares to diesel.
Perfect. The average investment for an LNG station, is there budgetary numbers you can give there?
That would vary greatly, again, by location and particulars of what the customer needs. I would really prefer if that sort of question could be directed to either myself or IMW salespeople directly, and we can provide budgetary pricing and designs for whatever situation a customer has.
Absolutely. Okay. Will I expect to lose much power when converting from diesel to LNG?
No. From what the engine manufacturers are telling us, the power availability is roughly comparable. So they're certifying their engines at a certain power rating and emissions level for new engines, and that's really most of what's going on in the U.S. today. There are not conversions of existing engines really being done right now. And from what I've been told, those power and performance levels are broadly similar to what you'd expect from a diesel engine of the same type. So no, you should not expect any decrease in performance.
Great. Why do we need a large containment area around the LNG storage tank?
That really is a code requirement. The codes that we follow are generally NFPA 52 for LNG and CNG vehicle fueling, and it's kind of interesting, but they do require a spill containment around the storage tank. We also provide emergency shutoff valves, so in the event of any kind of a leak, we're shutting off the valves at the tank. And so as far as I know in the industry, there's never been a case where a major spill is filled or partially filled the containment area, but it's in the code, so we have to follow those rules. I know I've seen plenty of stations in other countries where that's not a requirement and they have no spill containment walls at all.
Okay. Are siloxanes an issue with LNG?
Could you repeat, please?
Are siloxanes, I think I'm saying that right, siloxanes an issue with LNG?
Siloxane, I'm not sure I understand that one, I'm afraid.
Okay, we can follow that up after the webinar, no problem.
Okay.
So what level of training is required for truck drivers using LNG? And is that something that NorthStar provides?
Yes, typically what we would do is provide training of the drivers when the station is started up, and that training is typically a classroom safety session and then actual demonstration at the station itself. And that might be, it varies from site to site, but a couple hours is fairly typical, or half a day for a customer that has higher requirements. And then retraining annually is recommended strongly as well to make sure people keep using the correct practices. Many fleet operators, what we'll do is train the trainer essentially, so we'll train a couple people at the fleet and then they would retrain their drivers as needed for new hires and for annual retrainings.
Okay, perfect. Do you have an engine designed for LNG specifically?
Yeah, there's a number of LNG engines on the market and more under development. I don't know if I would say they are dedicated LNG engines out there, and in general they're built by the manufacturer based on their standard diesel engines. So Cummins has a number of engines out there, and others do as well. That we can probably follow up with a conversation with that questioner if possible to describe what's out there. There's quite a number right now.
Okay. Good question. What technologies are holding back LNG from being more widely accepted in the marketplace?
Well, I think what we'd say is that there's a couple things. It probably still gets to cost to convert both trucks and to build infrastructure. Now at Clean Energy, we've tried to take the infrastructure off the table by building out the network, but it's still quite a change to convert from fuel that's been in use for decades to something new and different, even if it does save cost. From a technology standpoint, the industry's been out there in the vehicle fueling for over 20 years, but things are still changing greatly now that the volumes of stations being built are going up. We have more competition entering the market, so everybody is innovating, trying to improve the stations, make them work better, perform better thermally and from a flow standpoint. So I don't think it's that we're missing a technology, it's that everybody's incrementally improving the technologies that we already have. I think definitely greater availability of engines and different types of engines would also probably help satisfy all the different needs out there as well.
Great. Our last question for now, we've got quite a few questions coming in, so after the housekeeping slides, I'll circle back, and if you'd like to stay until the end of that, great. If not, the questions and answers will be emailed out to all attendees. So our last question for now. When offloading into an LNG tank, either mobile or permanent, what amount of LNG is typically left in the offload tank, and is there a way to maximize the amount to offload?
Yeah, there's a couple things there. Normally, what we try to do is run the offload pump literally until we're starting to lose prime. So at that point, there's not hundreds of gallons of liquid in the tank or thousands. It's whatever is down at the bottom at the liquid level of the pump suction connection at the inner vessel. That amount should not be very much. I don't know, unfortunately, exactly what that volume might be. I'd be surprised if it's more than a couple hundred gallons at the most under normal circumstances. And but yeah, we can run the pumps all the way till we start to lose prime. So we try to suck the trailer as empty as we can.
Great. Thank you so much, Dave.
Okay, thank you.
So circling back, as mentioned, IMW now carries a full suite of LNG products using NorthStar's technology. Under our clean LCNG product line, we have Essential LNG, which is a space saver station, and an Enhanced LNG, our full retail station. Another product we've developed is Rapid LNG. It's a redeployable station with all major mechanical components integrated onto one skid. Our upcoming 3 webinars will be posted on the website by the end of the day today. Please visit imw.ca/webinars. The recordings for all webinars, any past webinars, will be posted on their respective landing pages as well. You can find those at imw.ca/webinars. We'd love to hear from you about your upcoming projects. You can find more information on our products at imw.ca. There's also a request for information form under the Contact tab on the right-hand side of the website. So we've got a couple more questions here for you, Dave.
Okay.
What is a typical LNG facility production per day?
The liquefier, that varies greatly. There are a number of providers of small-scale liquefaction plants that are selling into the U.S. right now. That might be anywhere from 10,000 to 15,000 LNG gallons per day, and they can be all the way up into the several 100,000 gallons per day, such as at the Boron plant. I think anything going into the LNG vehicle business, given the volumes that we all expect to use for that, would probably tend to be larger liquefiers in a couple 100,000 gallon per day range.
Okay. What do you see as the breaking point of fleet size or fuel demand when selecting a mobile fueling station versus a permanent fueling station?
Yeah, I think as I said before, it's probably not a hard number or a fixed number. It varies with application. I think certainly, less than 10 I think I'd be leaning more towards a mobile or small scale type of fueling facility, and hopefully that when we get above 10 and with prospects for future growth especially would justify the expense of a private station. Now if you can fuel at our public stations that Clean Energy has already built, then there's no lower limit. Any truck is allowed to fuel at those stations. They're public access with credit cards or Clean Energy fuel cards, and there's no impediment to fueling that way. So it's really just the private station where somebody needs a station on their back lot where there's a break point, I think, and maybe in the 10 truck or so range is where it starts to make some sense for a permanent station.
Okay. And what about a defueling station, the maintenance for that?
Yes, there are several that are on the market that can be purchased. We don't manufacture them ourselves, but we typically have bought them from Chart Industries and supply them to our customers. And they typically are a liquid cylinder or a pressure vessel that's on a forklift skid that can be used to defuel the vehicle back into this tank and then transfer from there into a different vehicle or possibly back to the station. So those are readily available and probably from a couple different suppliers as well.
Great. Well, these are all great questions, and if your question hasn't been answered yet, we will definitely be following up after the webinar. So big thank you to Dave Dixon. Really appreciate you calling in. That was a fantastic presentation. Thank you, everyone, for joining.
Yep, thank you very much, Amy. Thanks, everyone.
Bye now.